Okay, we're live, David.
Well, hello and welcome to this, the latest in our series of webinars from the Centre for Intelligent Design here in the UK. And today we're really pleased that you've joined us for this session. Let me first of all apologise. We've had a little bit of a delay in our start time simply because the weather has been somewhat inclement in Seattle and there were all sorts of communication issues. But happily, I can now say that these have been resolved. We have Steve with us and I'll be introducing him just in a moment. However, let me just welcome those of you who are new to this series of webinars and welcome back our previous participants. Over these last several months, it's been our objective to present a sequence of topics which provide an understanding of aspects of design and nature. And we've been especially keen to share evidence that calls the default understanding about the origin and complexity of living systems and their many characteristics into serious question. And asking questions like that, considering evidence like that, it's not only the healthy pursuit of truth, but it's the way that scientific understanding has developed and grown over the last several hundred years. In the series, which if you've been following, you will realize we focused on a wide range of topics: virology, origin of life science, orphan genes, paleontology, even some more reflective material with philosophical topics creeping in from time to time. We've had contributions from luminaries such as Mike Behe, Jim Tour, Doug Axe, Mike Denton, and Günter Bechley from Austria. And today we welcome our friend Steve Meyer back with us. He already actually participated in our webinar back in October 2020 with Jim Tour on the mystery of life's origin. And actually, if you go to our YouTube channel, you'll find all of the 9 previous webinar recordings there, together with some other resources which you're welcome to make use of. So make sure you sign up and get the notifications of future videos. Now, Steve Meyer, as well as being the director of the Center for Science and Culture at the Discovery Institute in Seattle, is the author of several best-selling books. He's well known around the globe now, and particularly well known, I think, for his first book, Signature in the Cell, which deals with the information enigma in the genetic code. And then soon after that came Darwin's Doubt, where he calls into question the default explanation for the emergence of new body plans in Cambrian animals. And you'll not be too surprised to learn that his Wikipedia entry is less than fulsome in its praise for his literary and other contributions. Nevertheless, his arguments, to my knowledge, have never been satisfactorily rebutted or refuted. Anyway, we were keen to have Steve back to discuss his latest book. Here it is, Return of the God Hypothesis. This is another significant contribution, both scholarly and persuasive. And essentially, it presents some groundbreaking scientific evidence for the existence of God based on discoveries in physics, in cosmology, as well as in biology. So today we're going to hand over to Steve in just a moment, but after he's spoken, you'll have an opportunity to interact. We'll have some questions if you just stick them on the YouTube chat. We'll moderate the discussion through my colleague David Williams, and we'll see how we go from there. But for the next 45 minutes, I'm going to hand over the floor to Dr. Steve Meyer. Steve's again, a great pleasure to welcome you, albeit virtually, to the United Kingdom. So over to you.
Well, very happy to be with you, David, and thank you for the invitation. Sorry to everyone for the delay. We're having some weathers that would be characteristic of Western Scotland. Lots of high winds, lots of rain, and it's knocked out some power lines. So I had to quick shift from my home office to the office downtown here. Anyway, I'm going to begin by sharing the screen and see if we can find the right. There we go. All right, let's get going. As David mentioned, my first book about the theory of intelligent design concerned the problem of the origin of the very first life and the origin of the information necessary to produce even a simple living cell. And in that book, I argued that the information bearing properties of DNA, the information storage, transmission, and processing system present in even the simplest living cells provide evidence for a designing intelligence. I won't recapitulate the whole of that argument here. We'll get to a bit of that later in the talk. But I mentioned that earlier book to put this book and its story and argument in context, because after I wrote Signature in the Cell and then made an additional elaboration of the case for intelligent design by looking at the problem of the origin of information as it arises in the context of the origin of animal form, many of my readers wanted to know, well, who do you think the designing intelligence is? What can we say about the identity of the designing intelligence? In my first two books, I argued for a designing intelligence of some unspecified kind and made the point that the theory of intelligent design is based on scientific evidence and a standard method of scientific reasoning, one characteristic of historical sciences, one that, in fact, Charles Darwin himself used and pioneered. So the theory of intelligent design can reasonably be argued to be a scientific theory, albeit of a particular kind, a historical scientific kind. And I further allowed or acknowledged that the theory may have larger metaphysical or worldview implications, but I didn't, in the first two books, attempt to spell those out. And I acknowledged that there might be different metaphysical interpretations attached to the theory of intelligent design rather than a more traditional theistic one, which I happen to favor. In this book, I decided to explicate what I think the metaphysical implications of the evidence for design in nature, what those implications are. And to do that, I expanded the data set, if you will, from looking just at evidence from biology to now bringing in evidence from cosmology and physics. One of the counter arguments to any theistic interpretation of design in biology was that the idea that, well, maybe the design was a product of some immanent intelligence within the cosmos. And if you just look at the evidence in biology, since that arises long after the beginning of the universe, it was at least logically possible that the evidence of design that we see in biology might be the product of an immanent intelligence within the cosmos, or possibly a transcendent intelligence. The biological evidence on its face doesn't seem to settle that question. And indeed, some leading scientists in the late 20th century and early 21st have actually posited a space alien designer as the explanation for the signature of intelligence, as Richard Dawkins put it in an interview that we find in The Cell. No less a personage than Francis Crick proposed that idea. So in this book, I wanted to take that possibility and other possibilities head on and ask, well, what can science tell us about the identity of the designing intelligence that I've argued is evident in life and the universe? And so that's what this new book is about. Now, I know that Richard Dawkins does maybe not have quite the same traction that he once had in public discourse in the UK, but I still appreciate him very much for his ability to frame issues very clearly. Of course, I disagree with his ultimate metaphysical conclusions. He's written a famous book called The God Delusion, and I've written a book called The Return of the God Hypothesis. So it's obvious we're not on the same page as far as our final conclusions. But I do appreciate his talent for framing issues and doing so very clearly. And he has a famous quote that I'd like to begin my talk with. He says that the universe we observe has precisely the properties we should expect if at bottom there is no design, no purpose, no evil, no good, nothing but blind, pitiless indifference. Where, of course, blind, pitiless indifference refers to matter and energy and nothing more. And this is an expression of his materialistic perspective, but also the claim that the evidence from the natural world, the properties of the universe, are what we would expect if that materialistic worldview or his scientific atheism were true. It's what we would expect on his perspective, on his worldview explanation of the evidence. And so what I want to ask in this talk and what I ask in my new book is the question simply, is that true? Are the evidences that we have about biological, physical, and cosmological origins, for example, what we would expect on a strictly materialistic worldview perspective? Now, of course, Dawkins has articulated this view, and many other of the new atheists have done so since 2006, 2007, when these books broke on the scene. And quite obviously, for those of a theistic perspective, biblical perspective even, this viewpoint presents a challenge. The biblical writers have long claimed that the very opposite. There's something about nature that seems to point to the reality of God. The psalmist says the heavens declare the glory of God and the skies proclaim the work of his hands. In Romans 1, you have the idea that from the things that are made, the eternal power and divine nature, sometimes translated wisdom of God, is evident in nature. So that's not very surprising, I suppose, that the biblical writers and the new atheists, in particular Richard Dawkins, disagree about what science tells us about the reality or existence of God. But what might be surprising is that the founders of modern science took a very different view of the relationship between science and religious belief than the modern new atheists. This is a front piece from a work of the early modern biology by John Ray, who's a fellow of the Royal Society. And the title of the book, The Wisdom of God Manifested in the Works of Creation, is a paraphrase of that passage from the book of Romans that I just read. You have this perspective that there's something about nature that reveals the reality and attributes of God in the writings of many of the early scientists, Johannes Kepler, Robert Boyle, and this perspective reaches an almost majestic quality in the writings of Sir Isaac Newton. In the General Scholium to the Principia, a theological epilogue that he wrote to the book, he made a very powerful and early fine-tuning design argument. Newton argued that the planetary bodies, the motions of the planetary bodies, could be understood by the law of gravity, which was the main idea that he explicated and put forth in the Principia. But he went on to argue that the initial position, the fine-tuning of the initial position of the planetary bodies could not be understood by the law of gravity alone, but instead that revealed a kind of design. And there's a famous quote in the General Scholium where he says, "Though these bodies may indeed continue in their orbits by the mere laws of gravity, yet they could by no means have at first derived the regular position of themselves from those laws. Thus, this most beautiful system of sun, planets, and comets could only proceed from the counsel and dominion of an intelligent and powerful being." Now,
Steve, I'm
yes.
very, very sorry to interrupt. We've got a black screen our end. I'm not sure your PowerPoint is coming through.
Oh my goodness.
So,
try again. Is that better?
no, still only got a black screen.
Black screen. Oh, I've been sharing all these lovely slides.
It says we're sharing your screen, but we haven't got your PowerPoint.
All righty. Maybe I stop share and start all over again.
Okay.
Let's try that. Any better?
Now we've just still got a blank screen. I tried to speak to Andrew there just to alert him to that.
Let's see what we can figure out here. We were sharing screen in the test and it was working fine, but we're not doing that now.
Screen sharing. Okay, let's maybe come off sharing and start again.
Yeah.
Are you selecting your PowerPoint screen when you go to share screen?
So this one here.
Did that do it, David? We have a slightly different appearance now that we've...
No,
It looks like we can see your mouse arrow, but we're not getting any image.
no, we're just getting a black screen.
Okay.
So unless you've got to start your PowerPoint your end.
Just restart everything here.
Yeah, we might close PowerPoint and reopen it.
You should be able to click on the PowerPoint screen. and then go into live, but it's just a black screen.
Thank you for stopping me. I'm sorry. I'm talking as if you were seeing things that you weren't.
Looks like we can see your cursor, but no sign of any image.
Mm.
Are they seeing anything?
No, just a black screen.
All right. We went out of PowerPoint and went back in. I mean, we may
Try
just,
shutting
we
down
can jettison the PowerPoint too, if we need to here, and just,
Okay, don't close that because that's the Zoom meeting.
okay.
Okay.
We'll try one more time. And if it doesn't work,
Well, you're gonna have to open it first, so that it's an available window.
okay, you go ahead.
Okay. It's the short one.
Hmm.
Okay. Okay, so that's launching it. Now we go back to Zoom. And we share it.
It should give you a selection of windows, windows which are open when you click on share screen, and then you click on the PowerPoint window, and that should then come up.
No, we're definitely seeing your mouse move, but nothing else.
Still okay. This is strange. We had it working in the test. Well, let's jettison the PowerPoint. Let me describe the book, and I'll tell the story of the book without the pictures. I'm so very sorry. Just bring up.
Yeah, that's fine. We've just got
All
you
right.
now, Steve.
Sorry, gentlemen and ladies. All right. Well, so I give a little prelim to the book or background. What I do in the book is I first tell the story of the rise and fall of what I call theistic science. That I show that the Judeo-Christian worldview and even biblical concepts played a very significant role in the rise of modern science. A key concept in the scientific revolution was the idea of intelligibility, that nature could be understood, and could be studied in a systematic way because it was the product of a rational intellect, and that rational intellect who built reason and order and design into the universe had also built our minds and made our minds in a way that allowed us to perceive that order and design. And there were a number of other concepts that came right out of that theistic background. The idea that nature was contingent on the will of a creator and therefore needed to be studied in a empirical way in order to determine the precise kind of order that was present in nature. Since God could have made nature any number of different ways, could have built lots of different types of order into nature, it was incumbent upon us to go and study. And so in the first part of the book, I discuss this theistic background to modern science, but then trace the story into the 19th century and show how things began to shift in the 19th century. In late 18th century Enlightenment philosophy and 19th century science, in particular, scientific theories about origins, Laplace's nebular hypothesis, theories in geology, and then especially theories in biology with the origin of species and the extension of evolutionary ideas, even to address problems like the origin of life. By the end of the 19th century, it had given us a kind of materialistic synthesis where scientists could tell the whole story of the origin of our planet, the origin of the solar system before that, but then the origin of life subsequent to that in a very seamless materialistic way. And that's been kind of the default way of thinking through much of the 20th century. And then in the second part of the book, I look at three big discoveries that are challenging that materialistic synthesis and are not what we would expect from a materialistic point of view. Thus, the Dawkins framing quote that I started with, that he says that the universe has exactly the properties we should expect. If at bottom there's no purpose, no design, nothing but blind, pitiless indifference. And I argue through much of the middle portion of the book, that the big discoveries that have been made about biological and cosmological origins are precisely not what we would expect from a standard materialistic worldview. In the first place, the big discovery that came in the 1920s and 30s, and then was confirmed by various various observational evidences in astronomy and developments in theoretical physics, was the discovery that the universe, as best we can tell, had a beginning. And by a beginning, we mean a beginning in space, time, matter, and energy. And so I describe in chapters 4, 5, and 6 of the book the discoveries in observational astronomy and theoretical physics that led scientists to that startling conclusion. Whereas through the 19th century, and even stretching way back to Aristotelian times, it was kind of the default view among scholars and scientists, philosophers and scientists, that the universe was eternal and self-existent and therefore needed no external cause or creator. But the shocking discovery of 20th century science, beginning in the 19-teens, 20s, 30s, was that the universe is expanding outward in all directions, and that as it does, the galactic material is getting further and further apart. But if you wind that time scale backwards and back extrapolate, you get to a point where the expansion must begin, and past which you can't further back extrapolate. The redshift evidence in astronomy was crucial to this. The observation that the light coming from distant galaxies is being stretched out in the red direction of the electromagnetic spectrum. And so there was this strong signal from observational astronomy suggesting that the universe was expanding in a sort of spherically symmetric way, suggesting, if you wind the clock backwards again, you get to a beginning point to the expansion and arguably the beginning of the universe. But then there were developments in theoretical physics that also reinforced that. In particular, Einstein's theory of general relativity, which implied that space and time were connected, and that massive bodies curve space-time such that in the forward direction of time, as the universe is expanding, space is getting more and more stretched out. Space is being created as the expansion goes. That's the implication of general relativity. But in the 1920s, first with Lemaitre, and then in the 60s with Stephen Hawking, there was a recognition that the equations of general relativity, when solved, implied a singularity in the finite direction of time in the past. That if matter curves space, then in the forward direction of time, as matter is getting more and more diffuse, then you get less and less curvature. But if you go in the reverse direction of time, then matter would cause the more dense concentration of matter at each successive point in the finite past would cause a tighter and tighter and tighter curvature to space-time, until finally you would get to an infinite curvature corresponding to zero spatial volume, which poses a profound challenge to any materialistic theory of the origin of the universe, because you can't put any space in no space, or you can't put any stuff in no spatial volume. In the book, I address a number of objections that can be made to the idea that the universe had a beginning, or that the beginning implies some kind of transcendent cause. We can get to those perhaps in the Q&A. But the first big and very startling discovery that was confirmed by two strands of evidence was the idea that the universe had a beginning. Evidence in observational astronomy and developments in theoretical physics, in particular the singularity theorems of Hawking, Penrose, and Ellis, later confirmed by developments in special relativity in something called the Born-Guth-Vilenkin theory. So that was the first big and very shocking discovery, not what you would expect from a materialistic worldview. Materialism always assumed that the universe was eternal and self-existent. Matter and energy in a materialistic worldview have always played the role that God has played for theists. It is the thing from which everything else comes. Sometimes it's what some philosophers call the prime reality, or a primitive in explanation. So if one physicist, Robert Dicke, put it this way, he said that if the universe, an infinitely old universe, would relieve us of the necessity of explaining the origin of matter at any finite time in the past, finite universe, however, raises the question of the origin of matter, space, time, and energy. And because matter, space, time, and energy come into existence at the beginning, then it becomes very difficult to provide a materialistic explanation for the origin of the universe, because it's precisely matter that comes into existence at that point. Before the beginning of the universe, there's no matter to do the causing. The second big discovery that I address in the book is the what's known as the fine-tuning, sometimes called anthropic fine-tuning of the laws and constants of physics, and also of the initial conditions of matter and energy at the beginning of the universe, what's sometimes called the initial entropy fine-tuning. And I describe a number of these different fine-tuning parameters. If we think just of that expanding universe that's been discovered by observational astronomy, one of the key fine-tuning parameters is the fine-tuning of the force that's causing that expansion, sometimes called or commonly known as the cosmological constant in physics. And an accepted value for the fine-tuning of just that one parameter is 1 chance in 10 to the 90th power, an exquisite degree of fine-tuning. In other words, if that force were a little stronger, we'd get a heat death of the universe. If it were a little weaker, we'd get the universe recollapsing, creating a giant black hole. And many fundamental parameters in physics have this character where the value that they have needs to be precisely what it is within very fine tolerances, or else we would not have a life-permitting universe at all. And so we have other factors such as the strength of gravitational force, the strength of electromagnetic force, the ratios between them, the more fundamental forces, the strong and weak nuclear forces. All of these fall within very narrow tolerances. The masses of the elementary particles, again, not too strong, not too weak. You have these multiple parameters that must fall must fall within very fine tolerances to allow for the possibility of life. And yet the probabilities associated with getting those parameters in those narrow life-permitting regions are extremely small, exponentially small, and there doesn't seem to be any underlying theoretical reason, physical theoretical reason for their having precisely those parameters. And that's raised a big question. Why? What explains that fine-tuning? And many physicists in the 20th century have reluctantly come to the idea that the fine-tuning may actually point to a fine-tuner, to an intelligence and an intelligent choice by a transcendent creator of some kind. Sir Fred Hoyle, who was a staunch atheist and who opposed the Big Bang theory on the grounds that it seemed to have theistic implications, he was quite explicit about that. He had metaphysical reasons for advancing the steady state, and he made that very clear. But in his own work, exploring the necessary conditions of producing abundant carbon in the universe, he discovered a whole host of fine-tuning parameters and eventually adopted a kind of proto-theistic position. In fact, he was quoted as saying a common sense interpretation of the evidence suggests that a super intellect has monkeyed with physics and chemistry in order to make life possible. And there we have somehow some slides. David, are those visible to your audience, or? Hello?
Yeah, these are visible.
All right.
Yeah, it's okay. We managed to get a copy of the PowerPoint our end, Stephen. So
okay, well, very good.
David's
well
going
done.
to follow on the slides with your talk.
Yeah.
So.
If can I advance or no, I can't. Okay. Okay, so I think what we'll do is we'll do more of a sketch of the argument and then allow more time for Q&A because we've had this problem. But that's very nice to see the slides. And one of the counter arguments to the fine-tuning design argument today is the idea of the multiverse, and we can address that in Q&A as well. One quick thing to say about it in passing is that one thing that's not widely known or understood about the multiverse hypothesis is that the multiverse hypothesis does not actually explain the ultimate fine-tuning of the universe. If there are many, the idea of the multiverse is that yes, there are these suite of fine-tuning parameters that individually and collectively are extremely improbable. But if we can posit enough other universes out there, we can imagine that the necessary physical parameters for a life-permitting universe would have had to have arisen in some universe somewhere, and we just happen to be in the lucky one. And therefore, what we view as evidence of design is actually a kind of observer selection effect. A problem with that hypothesis, which is not widely recognized, but should be, and I hope increasingly will be, I address this in my book, is that if those other universes are causally disconnected from our own, then they have no impact on anything that happens in our universe, including whatever processes were at work that set the fine-tuning parameters in this universe. So for the multiverse hypothesis to work, there must be some sort of connection between the different universes. There must be at least a kind of common cause. And in virtue of that, multiverse hypothesis, and in recognizing that need, multiverse hypothesis or proponents have posited universe-generating mechanisms that would allow them to portray our universe as a kind of a lucky winner of a great cosmic lottery. So though the universes today are not bumping into each other, they all have arisen from some kind of common mechanistic process or cause. And that's where the rub comes in with the multiverse hypothesis today, because even in theory, the different universe generating mechanisms that have been proposed must have. Let me rephrase that the different universe generating mechanisms that have been proposed require prior unexplained fine tuning, and whether those are based on string theory, or whether those are based on something called inflationary cosmology, or combining the two cosmological models, you don't actually get away from fine tuning with a multiverse. The multiverse, the fine tuning is just pushed back to the universe generating mechanisms that allegedly could produce new universes. So we can talk more about that in the Q&A, but this is a kind of a fascinating aspect of this discussion. The attempt to circumvent the common sense interpretation, as Hoyle describes it, has resulted in a very convoluted and theoretically unparsimonious explanation, but one that also doesn't actually provide an ultimate explanation for the phenomenon of interest, which is, again, the fine-tuning of these different physical parameters. That's why we have some scientists calling the universe a Goldilocks universe. The fundamental forces of physics are not too strong, not too weak. The expansion rate of the universe is not too fast, not too slow. The masses of the elementary particles, not too heavy, not too light. Everything falls in that sweet Goldilocks zone that allows that gives us a life-permitting universe. So that's the second big discovery, and I would again argue not at all what you would expect from a materialistic worldview or the scientific atheism of Richard Dawkins. The common sense interpretation, as Hoyle puts it, is that fine-tuning points to a fine-tuner. And I think the elaborate formulation of the multiverse hypothesis is evidence that this is not what you would expect on a common sense materialistic interpretation. If you have to resort to an explanation of that complexity to try to explain this phenomenon. Okay, the third big discovery that I look at is evidence of design in biology. And here, David, I think you can advance forward. The modern intelligent design hypothesis began to get a lot of currency in the 1990s when Michael Behe, the American biochemist from Lehigh University, published this book, Darwin's Black Box. And Behe, in the book, examined a number of the molecular machines that had been discovered over the last few decades in molecular biology, microbiology, and cell biology. The one on the slide just prior that was an animation still of something called the bacterial flagellar motor. Many people in the audience, I'm sure, will already be familiar with this. Behe made this famous. There's been quite a spirited debate about it. The flagellar motor is a striking piece of nanomachinery. It has a rotor, a stator, a U-joint, bushings, and a drive shaft. In some species, it rotates at 100,000 RPM and can reverse direction on a quarter of a turn. The slide you see on the screen here is meant to show that the parts of these nanomachines, and there are many inside cells, little walking robotic motor proteins that literally tow vesicles of materials along essentially railroad tracks inside the cell, the tubulin fibers. You have sliding clamps, you have turbines, and many, many other machines for doing practically every job required to process information in the cell. So we've discovered, far from being a simple homogeneous globule of undifferentiated protoplasm, as Huxley put it in the 19th century, the cell is an exquisite chemical factory that depends upon information storage, transmission, and processing, and that very fact has presented a huge conundrum for people trying to explain the origin of life. This slide is meant to show that those little nano machines are made of proteins. Proteins are made of sequences, precisely sequenced subunits called amino acids. And if those subunits are arranged properly, then the forces between them will cause the long chains of amino acids to fold into very specific three-dimensional shapes. And this is depicts that U-joint that was part of the flagellar motor. And so you can get the relationship between the amino acid subunits, the proteins that make up the machines, and the overall function of the machines. Now, Behe's made an argument for design based on what he calls the irreducible complexity of these nanomachines. And his argument is probably fairly well known. He's emphasized that these molecular machines typically require a core group of parts below which you cannot subtract any of the parts and still expect to have function or get function. So in the case of the flagellar motor, there's different versions of it. There's a 30-part version, and the 29, 28, 27, 28-part version does not perform any function at all. And so it poses a problem because natural selection selects for functional advantage, and yet until you get the full complement of protein parts, there's no functional advantage to select, and therefore those intermediate stages in the putative evolutionary scenario or trajectory would not give you a function that could be preserved by natural selection, and therefore there's nothing to select, nothing gets passed on, and evolution stops at that point. So Behe argues that this property of irreducible complexity is an indicator of intelligent design. There have been arguments back and forth about that. We can discuss that in the Q&A, but I mainly wanted you to see the relationship between the proteins and the molecular machines, and specifically the sequential arrangement of amino acids that's necessary to produce those proteins, because that's raised what I think is an even more fundamental question in biology, which is how do those amino acids get sequenced? And the answer to that was provided in the 1950s and 60s, and it raised perhaps an even more fundamental question. Then the picture on this screen is an animation still of a double helix, the DNA molecule with the A's, C's, G's, and T's, the nucleotide bases running along the interior of the molecule. And the answer to the question, how do amino acids get sequenced properly, turned out to be the DNA molecule, and in particular, the information it contains along the spine of the molecule. And so when people began to think about the origin of life after the molecular biological revolution of the 1950s and 60s, they suddenly had a new thing they had to reckon with, which is how do we explain the origin of the information that is necessary to build proteins, which are in turn necessary to maintain basic cellular functions. Can't have life without proteins. You can't have proteins without the information necessary to build them. So where did that information come from? In my book, Signature in the Cell, I called this the information enigma. And it remains an enigma within evolutionary within the field of evolutionary abiogenesis. There are not good explanations for that, and that's widely recognized. I think the next slide will help us. So yeah, this is the picture of the Watson and Crick, famed Watson and Crick discovery picture, with a picture of the structural formula for the DNA on the side. You can see that the information bearing axis is the longitudinal axis with the A's, C's, G's, and T's. In 1957, Crick, in 53, Watson and Crick elucidated the structure of DNA, but in 57, Crick put forward what he called the sequence hypothesis. And the idea of the sequence hypothesis is that those nucleotide bases, the subunits on the interior of the molecule that run along the spine of the DNA, are functioning like alphabetic characters in a written language, or the zeros and ones that we would identify in software today. That is to say that the nucleotide bases do not convey information by virtue of their physical or chemical properties, or their mass or their shape or anything like that. They convey information in virtue of their specific arrangement in accord with an independent symbol convention, which was later discovered and is now known as the genetic code. So you have a genetic text and a genetic code, and this information is crucial to building the proteins that keep cells alive. And that's raised, as I said, the crucial question in origin of life studies, which is, where did that information come from? In my book, Signature in the Cell, I look at the different classes of materialistic or chemical evolutionary explanations that have been offered for the origin of information, explanations based on chance, explanations based on physical law, or what's sometimes called necessity, and explanations that attempt to combine the two. And I show, for various reasons, both empirical and theoretical, each of these approaches have failed. But instead, there is a cause of which we know that is capable of producing information. Bill Gates has said that DNA is like a software program, but much more complex than any we've ever created. We know from our experience that software comes from programmers. And we know more generally that whenever we find information, especially if we find it in a digital or alphabetic or typographic form, and we trace it back to its source, we always come to a mind, not a material process, whether we're talking about a hieroglyphic inscription, or a paragraph in a book, or information embedded in a radio signal, or information in a computer program. Information traced back to its source always come to a mind. So the argument I made in my at great length in my book, Signature in the Cell, is that if we use the method of reasoning that Darwin used, a method known as inference to the best explanation, or the method of multiple competing hypotheses, where we're looking for a cause that we know from our uniform and repeated experience is sufficient to produce the effect in question, that the best explanation for the information necessary to produce, I think we could skip ahead, David, just a little bit more. I'll get you. Yeah, we've seen that one, maybe 2 slides. One more. Yeah, we see. Yeah, very good. Okay, so Darwin used, I'll back up just a little. Darwin used a method known as inference to the best explanation, or the method of multiple competing hypotheses. And that raised a question, well, what does it mean to be a best explanation? He was using this to try to reconstruct what happened in the remote past. And we're trying to explain it. If you're trying to explain an event in the remote past, his mentor, Charles Lyell, had a principle. He said that what we need to do is to invoke a cause that is now in operation. This is the title page from his famous Principles of Geology. And he says that the work is an attempt to explain the former changes of the Earth's surface by reference to causes now in operation. And when I was in grad school, I did my PhD on origin of life biology, and I was trying to understand and explicate Darwin's method of reasoning. It became clear that he was using this method of best explanation, or multiple competing hypotheses. And that raised a question: what does it mean? What does it mean to be a best explanation of an event in the remote past? And the common sense rule that historical scientists have used since the 19th century, starting with Lyell and Darwin and right up to the present, is that we should be looking for causes that are known to have the power to produce the effect in question. We should invoke causes now in operation. And when I came across this and began to think about it in light of this question of the origin of information, I ended up asking myself a question: what is the cause now in operation that produces information in a digital or alphabetic form? And the answer to that is, to me fairly obvious. It's mind, it's intelligence. An early information theorist who applied information sciences to molecular biology put it this way. So the creation of new information is habitually associated with conscious activity. And indeed it is. Again, whenever we see information and we trace it back to its ultimate source, especially if that information is digital or alphabetic, if it is expressed through a symbol convention, then we're looking at evidence of a mind, not a material process. And we can think of the Rosetta Stone with all those etchings. We wouldn't explain that by wind and erosion. Obviously, a scribe played a role. So as I've so that was a quick sketch of the argument I made in Signature in the Cell, but I now in the new book, Return to the God Hypothesis, I presented a case for 3 different unexpected discoveries from a materialistic point of view. The universe had a beginning. The universe has been finely tuned from the beginning, or since the beginning, from the beginning, and then since the beginning, long after the beginning, we have seen big bursts of new information in the biosphere. And so I ask in the book, in the third part of the book, I ask the question, well, if we look at this from a broad worldview perspective, which worldview can best explain these three key pieces of evidence? Materialism, I think, has troubles with all 3. Materialism doesn't expect that the universe would have a beginning. It doesn't expect the fine-tuning, and its explanation for the fine-tuning is actually inadequate, that being the multiverse. For various reasons, which I explain in more detail, both in the book and in Signature in the Cell, chemical evolutionary explanations of the ultimate origin of information have failed. Materialistic attempts to account for information have failed, but instead we know of a cause that does account for the origin of information. That cause is an intelligent agent. So that then I think should lead us to consider other worldviews. Deism does a pretty nice job of explaining the origin of the universe and even the fine-tuning, because a deistic creator is conceived to be an entity separate from the universe. If we're going to account for the universe having a beginning in time, we need to posit an entity which has causal powers which exist independent of the universe. So deism fits that bill, but deism doesn't explain well the origin of new information arising long after the beginning. It doesn't account for any evidence of design that we might have after the beginning of the universe, because a deistic creator does not, by definition, act after the beginning. Pantheism has much the same problems that materialism has. The pantheistic God is not a God with a conscious agency or mind, nor does it exist independent of the physical universe. In pantheism, God is coextensive with the material world. The pantheistic creator pantheistic God is in the physical world, and the physical world is an expression of the pantheistic God. So if the universe begins to exist, if the physical universe of matter, space, time, and energy have a beginning, then the God of pantheism would have a beginning as well, and neither entity could be posited as a cause that could bring the universe or bring the pantheistic God into existence. Just as matter in materialism, there's no matter before the beginning of the universe to do the causing. In pantheism, there's no God before the beginning of the universe to do the causing. So pantheism is also causally inadequate, in my judgment. Another idea that I explored was the idea of the space alien designer, the ET hypothesis. It might, sometimes called panspermia by the scientists who have proposed this. Crick and Dawkins even floated this as a speculative hypothesis in a long interview he granted in a film called Expelled several years ago. But this explanation has some obvious defects as well. Even if we grant that some sort of immanent intelligence in the cosmos might be responsible for the origin of life, the idea with panspermia is that life was created by an alien intelligence on some other planet and then seeded on planet Earth. Even if we grant that, it still raises the question of the origin of that space alien, which would have presumably had to have evolved from some eventually some simple one-celled organism itself, which would have also then begged the question as to the origin of the information necessary to get that evolutionary process going. And in any case, panspermia doesn't account for the fine-tuning of the universe or the origin of the universe itself. No being within the cosmos could be responsible for the fine-tuning of the physical parameters that were set at the beginning of the universe that makes its very life possible, nor could such a being be responsible for the origin of the universe itself. So as I look at these different worldview options, theism actually provides the best overall explanation. The kind of explanation we need requires a transcendent to explain the origin of the universe, the fine-tuning of the universe from the beginning, and big bursts of information coming into the biosphere since the beginning. We would need an intelligent agent that transcends or is separate from the universe, but which also acts within the universe after the beginning. And this is a very good, and this is exactly the kind of entity that theism posits. The inference to the best explanation method works as follows. It says, we will infer that explanation as best with, the best explanation approach is to posit something which, if true, would best explain the evidence. And if we posit a theistic creator, we have a causally adequate explanation of all three of the major discoveries that have been made about biological and cosmological origins, whereas the other worldview approaches do not provide an adequate explanation of at least one or more of these evidences. So in conclusion, a very famous historian of science several years ago said that the God hypothesis is a more respectable hypothesis than it has been at any time in the last 100 years. In the book, I go further and argue that the God hypothesis provides the best overall explanation for the big discoveries that have been made about biological, physical, and cosmological origins. And that these discoveries are not at all what we would expect from a materialistic worldview, but instead they are precisely what we would expect from a theistic worldview. And thus those evidences confer greater support on the hypothesis of theism than materialism or indeed any of the other metaphysical systems under consideration. And with that, I'd be happy to take some questions and field objections and have a discussion.
Good. Thanks, Steve. I think we'll ask David to take over now. Well done for soldiering through the difficulties we had with the presentation. Kindly, Andrew sent it to me and I was able to try and pick out where you were. So I hope that didn't disturb things.
No, that helped out a bit. Thank you, guys. Yeah, sorry for the technical difficulties all around today with the storm and everything here. So
yeah, no problem.
Well, let's get to the fun part. And,
yeah, David.
Okay. Well, thanks, Steve. Can I do a bit of background stuff first of all before we get into some specifics? What would you say to people that would say intelligent design has always avoided the question of who the designer is, and you've come a bit late to the party?
Well, I'm just a relentlessly curious person. And so I've been long interested in the question of design versus no design in biology, or apparent design. Dawkins has said biology is a study of complicated things that give the appearance of having been designed. We formulated the theory of intelligent design as an idea that contrasted with that core Darwinian idea. And in biology, I took the argument as far as I thought it could be taken, that it indicated the biological evidence points to a designing intelligence of some kind. I never thought the space alien designer was a very compelling explanation, because it just kicked the problem of the ultimate origin of information out into space. But people who are curious naturally want to ask the question, what is, or who is the designer, and what can science tell us about that? And so that's why I wrote this book. The theory of intelligent design does not commit itself to a particular metaphysical interpretation. I wanted to explore the metaphysical interpretations of the evidence that we have for design, but the theory of intelligent design is based on the design detection apparatus or methodology that William Dembski developed, and also the method of inference to the best explanation. But I think you can once you've inferred that a designing intelligence of some kind was responsible, you can ask the question, well, what can other scientific evidence beyond biology tell us about the identity of that designing agent? And I think it can tell us quite a lot. I don't think it can settle questions between different theistic worldviews or different theistic religions. I think it gets us to a basic theism. And that's the argument I made in the book.
You stole my next question. Where do you draw the line? So you draw the line at basic theism, but no further beyond that.
Well, I think there are ways to adjudicate those the questions between the different theistic religions, but I don't think the evidence from the natural world gives us the ability to do that. I think even if you take the biblical idea of say Romans 1, the idea that there's something about nature that reveals the reality of God, what the biblical text suggests that we can know the reality of God and something of his attributes, his power and divine nature, wisdom. But I don't think that enables us to, as some apologists have claimed, deduce the plan of salvation, or whether it's Judaism, Christianity, or Islam. I think those questions have to be addressed in some other ways. So my argument, I think, gets you to basic theism. And there are, of course, non-religious theists, and then there are different types of monotheists who have different coming out of different religious perspectives. And I think, across the board, people have liked this argument within the theistic world. But anyway, that's my take on it. I think there are limits to how far you can push natural theology.
Well, you keep stealing my question, Steve.
Oh, sorry.
Is this natural theology? Is this just your modern version of natural theology?
I think this book is a work of natural theology. I would shirk from that label. In the end, I think there's been an awful lot of emphasis in these discussions about, well, is something science, or is it pseudoscience? Is it science, or is it philosophy? Is it science, or is it religion? I'm mainly interested in what's true and what we can tell from the evidence using our best methods of reasoning. So I use this method of inference to the best explanation in the book. I supplement it with Bayesian analysis in some places, which I found to be a very helpful tool. And I try to reason this through real carefully and not avoid addressing these big metaphysical questions. I mean, that's just part of why we're all interested in this. So I think the theory of intelligent design has a well-defined sort of remit or purview that's based on the applications of design detection methods to analyzing systems, especially in biology. But when we begin to use some of the same methods and bring in the physics and the cosmology, I think we've got a pretty strong case for theism. So I don't know I'm happy to call that natural theology, but I think theism provides the best explanation of these evidences, and therefore I think that provides evidential warrant for the conclusion that God exists.
Okay. Just before the next one, let me just remind those watching or listening, if you want to post any questions you've got in the live chat, and hopefully we'll get around to as many of those as possible before Steve's got to go. Let's go back to the beginning then, Steve, the very beginning. I'm going to refer to it as the Big Bang. What does that rule in and out?
Well, the Big Bang is the name of the theory. It was actually, it's interesting because it was the Big Bang as a term was coined by Hoyle as a pejorative because he wanted to ridicule the idea, but it caught on and then it won out. The cosmology discussion in the book is nuanced and more detailed than I can convey in the in a short presentation. But let me speak to an objection or a concern that might be in the back of certain minds, and that is that the evidence from the observational astronomy is pointing back towards a beginning. If you back extrapolate, you get to a point past which you can no longer extrapolate any further. You get a convergence of all the galactic material at a starting point. If you apply general relativity to understanding the origin and history and evolution of the universe, and it also points to a singularity. There is in the application of general relativity a loophole or a caveat that needs to be acknowledged, and that is that the idea of general relativity, or general relativity as a theory of gravity, works all the way back to the beginning, but it works almost back to the beginning, but there's a tiny smidgen of time and corresponding space, sometimes called Planck time, in 10 to the minus 43rd of a second after the beginning. And in that tiny bit of time, and the space corresponding to however much space could have expanded in that time, we're not sure how gravity would have worked. And so some people have said, well, hey, then we can't back extrapolate all the way to the beginning. We can get almost all the way back, and then we don't really know what happens in that tiny smidgen of space. And as a consequence of that, something called quantum cosmology was developed in the 1980s, which attempted to account for the origin of the universe, not as the result of a transcendent creation event, which you might invoke if you could be absolutely certain that the universe, the physical universe, had a beginning, that time and space, as well as matter and energy, began. But rather, quantum cosmology attempted to explain the origin of the universe as a consequence of the physics of quantum mechanics, the physical laws of quantum mechanics, and ideas about what gravity would have been like in that early quantum epoch. And in the book, I take this head on and show that if you adopt for a quantum cosmological approach, you have theistic implications. You still have theistic implications. That if you say there was a definite singularity, the evidence is pointing, as best we can tell, to a beginning, and infer from that there must have been a transcendent cause beyond the universe, you have you can revive the Kalam cosmological argument. But if you go with the quantum cosmological approach, you end up with some strange results. One of which is that the ultimate explanation for the origin of matter, space, time, and energy in our universe is a set of mathematical equations. So you have math producing matter. But math is causally inert in our experience, and math is also conceptual and only exists in minds. And so even one of the architects of quantum cosmology, Alexander Velikin, has raised this interesting specter that if math is conceptual, if it exists in the realm of the mind, he says on the very last page of his book, Many Worlds in One, he says, are we therefore saying that the universe came from a mind? And the other thing, which I go into a lot of detail about, is that the mathematics, it's something called the Wheeler-DeWitt equation that produces something else called the universal wave function, which is the explanatory entity in quantum cosmology. That the math that gives you that explanatory entity has to be very precisely, finely tuned to give you the right kind of universal wave function that would give you a universe like ours. So in other words, you got to fiddle with the math. It's got to be finely tuned to give you the right outcome. And the people doing the fiddling are the theoretical physicists. They're inputting information into their mathematical apparatus in order to get the right kind of mathematical outcome that would give them an explanation for the origin of the universe. And I think what they end up modeling inadvertently is the need for information to give you a universe and a mind to give you the information. In other words, intelligent design at a cosmological level. So even the attempt to get around the beginning, I think, brings you right back to another theistic conclusion.
So does that, as I say, I'll call it the Big Bang still, but does that mean the Big Bang rules out materialism?
Well, I think the Big Bang does not provide a materialistic explanation for the origin of the universe. The Big Bang is not a description of the cause of the universe. And a lot of people in the creationist movement have often objected to the Big Bang, thinking that the physicists and the cosmologists are saying the Big Bang caused the origin of the universe. The Big Bang is not the first cause. The Big Bang is the first event. It's the first effect. And it's an effect that, by definition, because it involves the emergence or creation of matter, space, time, and energy, cannot be explained adequately by a materialistic cause. Now, the way to try to get around that strong statement that I've just made is to say, well, but are we absolutely sure that the universe, the material universe of matter, space, time, and energy had an absolute beginning? There is a proof based on special relativity called the Borde-Guth-Velikin proof that does take you back to a singularity. So I think that is arguable. But my point, what I do in the book is create what philosophers call a robust argument. I say, if you go this route, you have a theistic implication for one reason. But if you don't like going that route, you want to pull back from saying the universe definitely had an absolute physical beginning of matter, space, time, and energy, but it emerged out of this mathematical array of possibilities, then you've got another theistic implication for a different reason. Math is conceptual, it exists in minds. So if you want to posit math as the ultimate explanation for matter, then you're inadvertently invoking a pre-existing mind for another reason. So, and I unpack this argument in a lot more detail in the book. So on one formulation of modern cosmology, you have an absolute beginning that cannot be explained materialistically. On another formulation, you have the need to account for matter, space-time, and energy coming out of math, which is, again, not a materialistic explanation. So I think materialism is on the ropes as far as cosmology is concerned. Yeah.
Okay. I'm going to take things in order, and there's a question that's come in as we're on the Big Bang. I'll read it word for word. It says, in the Big Bang theory, how can all the atoms in the universe be made in stars if both fusion and fission stop at iron? If heavy elements are unstable, saying you can't start with both seems unlikely.
Can you try me on that one again? Sounds like a very well-informed question, but yeah.
It says, in the Big Bang theory, how can all the atoms in the universe be made in stars if both fusion and fission stop at iron? If heavy elements are unstable, saying you can't, it might be saying you can start with both, seems unlikely.
I'm not sure I can answer that question precisely, but I can speak to something else very similar to that, and that was what was bothering Hoyle. Hoyle wanted to know how could you account for the amount of carbon in the universe, the abundance of carbon in the universe. And he eventually realized it had to do with processes that were going on inside stars. He was looking at stellar nucleosynthesis. And it was as a result of some really brilliant insights he had that we came up with a very good theory about how carbon could have been formed. But an implication of his theory required a precise fine-tuning of something called the carbon 12. It had to have a particular resonance or particular energy level that was not known to physicists at the time. And he encouraged some physicists at Caltech to go out and look for that resonance level. They found it. And for that to exist, a whole lot of other things had to be finely tuned: gravitational force, electromagnetic force, the relation between the two. So a lot of the first fine-tuning parameters that I discussed in the lecture were a consequence of Hoyle's attempt to account for the origin or the abundance of carbon in the universe, which was something that was hard to explain at that time for both the Big Bang theory and his rival steady state theory. So questions about the origin of the elements, which your questioner alludes to, were very, very, very important and of a high order of concern to the early cosmological theorists. And it was in virtue of the questions like that that we came to understand a number of the necessary fine-tuning parameters.
Okay, and another question which goes back to what you were touching on moments ago, says, with many scientists accepting the universe, quote, creating itself, close quote, and justifying it by using laws such as gravity, brought forth by Stephen Hawking, wouldn't that reasoning reinforce a law maker as well?
Well, this is there's this famous quote from Hawking, and our colleague and friend John Lennox has critiqued this very vigorously. But Hawking said, because there is a law such as gravity, the universe can and must create itself out of nothing. It must create itself out of nothing. And Lennox points out right away that if there is a law such as gravity, that's not nothing. And so this statement is contradictory. I think the problems with Hawking's statement, there are other problems with Hawking's statement, because this was a pithy way of his summarizing the ideas of quantum cosmology. And as I mentioned, quantum cosmology explains the origin of the universe as a consequence of a mathematical function called a universal wave function that describes a range of possible universes or gravitational fields that could exist. And you only get a universal wave function by solving a prior equation describing how gravity would work in the early part of the universe called the Wheeler-DeWitt equation. So there's this whole mathematical apparatus that pre-exists the universe. The other thing about quantum cosmology is that it doesn't get rid of the singularity. It actually presupposes the singularity. So it was presented by Hawking in the 1980s as an alternative to the sort of Kalam cosmological argument and the interpretation of the Big Bang as having as requiring a theistic creator. And his popular book, The Brief History of Time, he was quoted as saying, "What need then for a creator if we can show that the universe emerged out of this mathematical this array of mathematical possibilities, and that the math of quantum gravity somehow explained the origin of the universe." But it is indeed the math of quantum gravity, which is all they have to work with. There is no universe. There's no matter, space, time, or energy prior to that. And the singularity is part of the mathematical apparatus. So you still have to explain how you get everything out of nothing. And the putative explanation is you get everything out of nothing except for all these mathematical equations or a mathematical function in a big, hairy functional differential equation, which you can't solve unless you put information into it, and the information going into it is coming from the theoretical physicists. So even if a line I had in the book was, even if you explain the origin of the universe, the origin of matter, space, time, and energy apart from any matter and energy, you still need information, and the information in the mathematical modeling is coming from the minds of physicists, which I think suggests they're modeling the need for a transcendent mind to generate a universe.
Okay. Now, adopting a sort of chronological approach here, we've done the Big Bang, or the very beginning, or close to the beginning. The next chronological argument would then be the fine-tuning, either that goes into the start. I think you distinguish between fine-tuning at the start and continual fine-tuning.
Right. I do in the book. I didn't talk much about that in the lecture.
So just before you answer that, let me ask this question that's come in.
Sure.
It says this, because it sort of attacks the whole base of that argument potentially, and it's this: how secure is the evidence from fine-tuning? There are those who argue that there is a fifth fundamental force and that there is recent evidence for it. Might the fine-tuning be vulnerable to defeat?
I address that objection head on in the book. Sometimes physicists will say, well, let me start first with, there's a wonderful book by the Australian physicist Luke Barnes, who called The Fortunate Universe, which he wrote with his Cambridge PhD supervisor. Barnes is a theist. The supervisor is an atheist. At the end of the book, after they present all the evidence for the fine-tuning parameters, they then have a debate about how to interpret the fine-tuning. But they also list all of the mainstream elite physicists who accept the fact of fine-tuning. So one quick answer to that is I don't think there's a lot of dispute about the reality of the fine-tuning. There is, however, the claim that, well, perhaps there are, in the end, will be no free parameters. The idea is that all the fine-tuning, all the different laws of physics have these constants of proportionality, which have no underlying physical reason for their precise value. And the claim is made, well, maybe there'll be one universal law that will allow us to reduce all the four fundamental laws of physics to one law. And that law will also explain why all the fine-tuning parameters have the values that they do. But there's a kind of conceptual problem with this that I explain in a lot more detail in the book. But laws of nature have a particular character. They describe highly repetitive or redundant patterns. They capture a lot of the common elements of a lot of phenomena in a single expression. So from an information theoretic standpoint, they're what information scientists call redundant, or rather they describe redundant patterns, repetitive patterns of order. The fine-tuning parameters are highly idiosyncratic values or strengths or or features of the universe that do not lend themselves to reduction to a single law or algorithm or rule. And many of the parameters are not even expressed. In fact, most of them are not even expressed in the same units. Some are unitless and some have very different units from each other. So it's hard to imagine how you could have a single law that would reduce all those different parameters, the values of all those different parameters, to one single expression. They're too random, they're too complex, they're too idiosyncratic to be reduced to a simple law-like expression. And even if you could, there's the further problem that the universe as we find it has specificity in the configuration of matter and energy. And the laws of physics don't capture that specificity without the gift of what are called boundary constraints and initial conditions. We have to know more than just there's a proportionality relationship between matter and gravitational force, that the more matter you have, the stronger the force. To explain the universe as we have it with all its specificity of configuration, you need that extra information about what are called boundary conditions or initial conditions, about the conditions in which we find matter, not just the general relationships between forces and matter. So even if there was a new one universal law that reduced all the other four laws, you'd still need a lot of information about the conditions of matter and energy in the universe to describe accurately our universe, in which case you'd be right back to the same problem, which is fine-tuning.
Okay. Now, would it be correct of me, potentially too simplistic, to say that it is fine-tuning which has driven the multiverse theory as opposed to evidence?
I don't really like to speculate as to motives, because some physicists will tell you that the fine-tuning is something that falls out of certain interpretations of quantum mechanics. The many worlds interpretation, for example. But there are some physicists who will tell you that, they will acknowledge, like Leonard Susskind has acknowledged, this is a highly counterintuitive explanation. But he said, if without it, we'd be hard pressed to answer the ID critics, he says. So there are some physicists who say openly, it's not the normal type of physics we like to do, but it's preferable to the alternative. So I think there is a bit of that. I think there are theoretical reasons whereby you could consider that the possibility of the existence of other universes. My point is that even if you posit the existence of other universes, simply positing those other universes does not explain the fine-tuning in our universe, unless you also posit a universe-generating mechanism, which by necessity and even in theory requires prior unexplained fine-tuning. And so then you are right back to where you started. You haven't explained away the ultimate origin of fine-tuning. And yet in our experience, what we call fine-tuning, which is a very precise calibration of multiple parameters in order to achieve some functional outcome, and we find this in internal combustion engines and fine French recipes and in computer code, what we call fine-tuning is invariably the product of intelligent agency. So given that the multiverse doesn't provide an ultimate explanation for fine-tuning, in fact, leaves the ultimate fine-tuning required unexplained, and given that we do know of an explanation or a cause that does produce fine-tuning, and that being intelligence, I argue that the fine-tuning that we find in the physical universe, which is a necessary condition of a life-conducive universe, is best explained by a transcendent intelligence.
Okay. Right. I'm going in a second. I'm going to move on to the biological complexity argument. But
doing this very logically, David. You must have a background in law or something, I think.
Just pausing there a second.
Yeah.
As I understand it, at this point, you have ruled out materialism. You have ruled out deism because the fine-tuning and continued fine-tuning requires input after the initial action at the beginning, or there can't be any deism rules out continuing action or interference. And you've ruled out pantheism because that would mean the pantheistic creator having to be created itself. that's my very inelegant summary of it.
Yeah,
where
that's
we've
good.
got to.
And also the pantheistic creator lacks a mind, so
Yeah,
it's not a
so-
conscious agent. So fine-tuning
So what
points
do you say
to
to what does it really rule out deism if the deistic creator, if I can use that phrase, pre-programs at the start to cover all of those things that you say have to be covered on a continuing basis?
right. I have a big discussion of that excellent question in chapter 15 of the book. The short answer is that there is not an in principle reason that the deistic, well, there are some in principle reasons, but I'm not arguing that it's logically impossible that a deistic creator might have front end loaded the design at the very beginning of the universe. But I argue that it's scientifically implausible in the extreme. Just to start with, we don't even get atoms until 380,000 years after the beginning of the universe, till things cool out of the plasma state in order for such that atoms could form. Information in the biological realm comes into existence in a fragile in a fragile molecule called deoxyribonucleic acid. The idea that information was somehow front-end loaded 13.8 billion years ago and persisted through time, and then was able to arise or be generated to produce life is really implausible. But there's something about the DNA molecule itself that I think even strengthens this conclusion. The information in DNA is stored in the sequence of nucleotide bases. And when you examine the DNA molecule, it turns out that there are no physical or chemical bonds between the bases that determine its sequential arrangement, which is what constitutes the information that DNA contains. That means that even if we were to posit the preexistence of the sugars, the phosphates, and the nucleotide bases in some favorable prebiotic environment, that there's nothing about the physical and chemical properties of those constituents that would determine an information-rich arrangement. All of the different possible arrangements, some which are functional and informational and some which are not, are equally probable. There's nothing about the chemistry that determines the sequencing, and therefore nothing about the chemistry that can explain the origin of the information. And the point I make in the book is that if the physical chemical properties of the relevant and complex subunits of DNA do not explain the origin of the information in the molecule, then surely the elementary particles in the first atoms after the plasma state, or even going further back all the way to the beginning, the elementary particles in the plasma state did not have a specificity that could explain the origin of life. Information must arise much later, and therefore the evidence of design that's provided by that information is pointing to a designing agent that is active in the creation.
Okay, you've moved me on to biology and you've moved me on to information. Just to hold this thought, because David Galloway is going to come in after this question on to do with God of the gaps, which could apply to all of these areas, but certainly historically has often tended to be applied to biology. The question on information that leads into that is this: noting that DNA holds coded information, is there anything in information theory equivalent to the second law of thermodynamics?
I think one of our guys, William Dembski, has formulated a law of conservation of information, which is precisely analogous to the law of the second law of thermodynamics. But there has been, I think, a confusion about the second law in these arguments about biological origins. There was a longstanding creationist argument that said, well, evolution violates the second law because you're going from order to from disorder to order. The evolutionary response was, no, it doesn't, because though the second law describes the tendency of large systems to go from order to disorder over time. You can have localized environments where you can get order arising spontaneously at the expense of disorder arising someplace else, which is true. But the problem with applying that to discussions of biological origins is we're not trying to explain the origin of order in the sense of a vortex or a spherically symmetric wave current or something like that. We're talking about information, and information and order are not the same thing in the information sciences. All information is a form of order, but not all order is informational. And what Leslie Orgel, the great Origin of Life biochemist, called specified complexity, is what needs to be explained in life. So I used to illustrate this with the two Coke bottles that were put together with they had a fastener, and there was blue liquid inside with some sparkles. And if you put some energy into the system, that localized system will produce order spontaneously, a vortex. But the little sparkly things in the food coloring do not arrange themselves into a statement like intelligent design is a great idea, or there's no you can have order without information. So in thermodynamics, you can get a spontaneous order can arise spontaneously with an input of energy, but that does not explain the origin of information. That remains unexplained. And also it is the case that information tends to degrade over time, not to arise spontaneously. So this was Dembski's idea of the conservation law of information.
David, did you want to come in with your...
Yeah, sure. Thanks, David. So, Steve, I mean, this is all very persuasive and you've made the case very well. However, the one thing which I find, trying to be some kind of amateur design proponent, the one pushback that keeps coming back again and again is the idea, well, it's just a God of the gaps argument. It's just, you're just filling in with God when there is a gap that you can't otherwise understand. And I know you've made the point, in fact, you've addressed it in the book, the God of the gaps idea, saying that, that's an argument from ignorance. And this case that you're making is not an argument from ignorance, it's an argument from what we actually know and can demonstrate and the implications of that. So why do you think this God of the gaps idea just keeps resurfacing again and again? Are we missing something, or are they missing something? Why
it's a standard, counter argument to the case for intelligent design, and in the book I take the objection in two phases. I first look at the design argument in biology as it arises in biology, or as we develop it in biology. And the claim is, well, this is God of the gaps. Well, in inferring a designing an agent of some kind, in the initial work that I did, I wasn't inferring the existence of God, but I was inferring a designing intelligence. But I wasn't doing so on the basis of an absence of knowledge. I was doing it on the basis of what we know about what it takes to generate information. An argument from ignorance has the form explanation or cause X does not produce effect Z. Therefore, cause Y must have produced effect Z. That's a fallacious inference unless we have positive reasons for knowing that cause Y can produce effect Z apart from cause X's inability to do so. So that is the formal or informal fallacy known as an argument from ignorance. We're not arguing that way for intelligent design. We're saying that natural processes have not demonstrated the capability of producing specified complexity or specified or functional information. But we do know of a cause that has demonstrated that power, that being intelligence or mind. Therefore, the presence of information in a living system is better explained by a mental or intelligent cause rather than an undirected material cause or process. That's an inference to the best explanation based on our knowledge of cause and effect, not an argument from ignorance. Now, in the book, because I am arguing for God as the overall best explanation for the ensemble of evidence we have about biological, physical, and cosmological origins. Someone could more plausibly argue that I'm making a God of the gaps argument. But again, what I show in the book is I'm not arguing from ignorance. I'm arguing from I'm using an inference to the best explanation and referring to the causal powers associated with one causal postulate, namely a transcendent theistic creator, as opposed to the causal powers that are associated with other possible causal postulates, such as a deistic creator or a materialistic or a brute materialism, or a pantheist or panentheist. So I look at the different worldview systems and the entities they posit as ultimate causes, and ask whether or not those entities have the causal powers associated with them that would allow them to function as causes for the things that we see in the universe, or the events that we see. And it turns out that of that ensemble of possible explanations, only theism posits an entity with causal powers. This would be positive attributes that would be capable in theory of producing the effects in question. So theism provides a better explanation, and it is a best explanation strategy, not an argument from ignorance.
So I'm going to copyright this if it's correct and if you like it, but would a pithy way of summing that up be that it's not God of the gaps, it's God of the facts?
I think that's right. Or what my chapter title was God of the Gaps, or Acts of God. Can we have evidence of acts of God? I think we can.
Okay. I've got one more question for you, and it's this. What will be lost in the scientific endeavor if people at the very least entertain the idea of an intelligent design or designer?
Nothing at all. This is, the big worry about the God of the gaps objection is that positing God or positing a designer without specifying its identity, either way, would be a science stopper. But one quick way of refuting that is to look at how fruitful the God hypothesis was in fostering science in the beginning and in guiding science in its early phases. Historians of physics recognize that the Principia was a theological project, that Newton was attempting to reveal the mathematical principles that underlay the function of the physical universe in order to give glory to God. I remember one of my tutorials when I was in Cambridge about Newton, when I did a whole series of essays on the whole debate about universal gravitation. And my Cambridge supervisor said, if you miss Newton's theism, you've missed everything. It was the animating perspective that gave rise to his science, that gave inspiration to his science, and he made a lot of great discoveries. Fast forward, let me give you an example that shows the fruitfulness of intelligent design as a scientific hypothesis. I've argued, and other ID proponents have argued, that the information-bearing properties of DNA and RNA provide evidence of the activity of a designing mind. A program requires a programmer. In opposition to that, some evolutionary biologists have argued, well, then why is there so much junk DNA? Why does so much of the DNA not perform the function of coding for proteins? And when this was discovered in the 1970s, that about 3% of the DNA codes for proteins and 97% doesn't, it was immediately assumed by neo-Darwinists that the non-coding regions of the genome were junk. They perform no function. And beginning in the late 1990s and the early 2000s, a number of the proponents of intelligent design said, okay, fair enough. This provides a nice critical test of our two models. You say the non-coding regions are non-functional. we accept that mutations are real processes and that they can degrade information, but we would not on our model. We acknowledge this. On our model, we would not expect 97% of the genome to be non-coding and to be junk. So we predict instead that the non-coding regions of the genome will turn out to be importantly functional. And a number of papers were written in the early 2000s. And finally, there was a major study called the ENCODE project that came out and was published in 2011 that confirmed effectively the ID prediction. People weren't too keen to acknowledge that, but James Shapiro, a leading cell biologist at the University of Chicago, prominent evolutionary biologist, wrote an article in the Huffington Post acknowledging that Richard Sternberg, a design proponent, was the first one to do serious work explicating these non-coding regions because he expected to find such a function. And he said, though Sternberg and I have different evolutionary philosophies, it must be acknowledged that he saw this coming first. So I think intelligent design as a research program in biology, which doesn't require inferring anything about whether God was the designer or not, can be a very fruitful program. But I think theism generally has been a huge inspiration for science, and there's absolutely no reason that it can't be again today.
Okay. I said that was the last question, Steve. So it just remains for me to say thank you very much. I know we've had some technical difficulties, but the content, as always, has been fascinating. So thank you ever so much for taking the time to share that with us. And
thank you for the great questions and your audience for providing them, and for all of you for inviting me. Thanks. Yeah.
And I'll hand you back to David Galloway.
Yeah.
Okay, well, thanks, David, and thanks, Steve, very much for a most stimulating session. Sorry we had some difficulty with the visuals earlier on, but hopefully we managed to avoid spoiling your enjoyment of it despite that. Well, Steve, thanks again. I'm sorry you're having such difficult weather in Seattle. You know, here we are in the west of Scotland, and it's just been a beautiful day today. Maybe it's something to do with COP26 being down the road for the last couple of weeks, I don't know. But let me just remind our viewers and participants to make sure they visit our C4ID website. You can sign up there to make sure that you get our regular communications. If we have your email address, then we'll keep you informed of future webinars. We're very excited to have two well-known ID supporters in the next couple of months. In December, we're going to welcome Michael Egnor, who's well known in this field, a neurosurgeon from Stony Brook in New York. And then in January, we're going to have John Lennox on for a more conversational style event in the middle of January. So we'll keep you posted with these. Make sure also to see our YouTube channel. We've got all the previous webinars recorded there, and you can pick these up. And also bear in mind, Steve's organization, the Center for Science and Culture, have a superb website with loads of fascinating resources, and you'll find that at discovery.org/ID. And remember, this has all been about the book, Return of the God Hypothesis, available from all good booksellers. But there we are, folks. That's it for today. Thank you very much for joining us, and we look forward to seeing you in the next session, which will be with Michael Egnor in mid-December. We'll send out the details